Hello, and welcome to today's lesson where we're going to look at making that decision. When are we going to use law of sines? When are we going to use law of cosines? That's an important step because there is a lot of extra work to do. Okay, so now, when we're looking at the situation, do you use right triangle trig, sine, cosine, tangent? Do you use law of sines or do you use law of cosines? Now, they're actually listed in this order because this is the order that you want to look for. As we go through, we want to find anything that is a right triangle and know that we would use sine, cosine, tangent to go through and solve those right triangle situations. Okay, so anytime you see that 90-degree angle, you want to use your right triangle trig because that is an easier process. Now, when we talk about the law of sines versus the law of cosine, we want to remember what they look like. For the law of sines, sine of A over A equals sine of B over B. A very nice, easy ratio. Okay, but notice what you need. You need 3 out of the 4 pieces, and the pieces have to go through and match up. Now, when we use law of cosines, c squared equals a squared plus b squared minus 2ab cosine c. You can see there's a lot of pieces there. So that's your last case scenario. Okay, and we want to use that situation when we're looking for the pieces overall. The number one rule is when we're working through these to kind of help separate the two. If you're looking for a side length, you need those opposite angles. So you always want to think about what you're trying to find in the problem. Okay, this problem we're trying to find angle B. And what you want to do is kind of draw your arrows. I've got an angle here, draw an arrow to the side. And if you've got 3 of the 4 pieces you need between the angles and the sides, that's when you can use law of sines for that problem. Okay, now we look at the next triangle here to the right. You want to look at what you have. Okay, we have an angle, we have a side opposite. Okay, so law of sines based on that would be in play. The problem is I don't have another angle. So this would be a law of cosines situation. Okay, jumping down to our next one here. Okay, we've got side B. Okay, and I'm going to try to stay consistent here. Okay, circle the angle, arrow across to the side, circle the angle, arrow across to a side. Okay, I've got those 2 pairs, and if I have the 2 pairs and only one thing is missing, then I know it's a law of sines situation. Okay, same thing here. Angle, side opposite, angle, side opposite. I have 3 out of the 4, so that is a law of sines situation. Okay, so now if I look at this next one, I've got angle, side opposite, and the side opposite is what I'm looking for. But if you notice, I don't have another angle to pair up with an opposite side. So this is a law of cosine situation. Okay, just a couple more examples here, really kind of looking at the pattern. Okay, in this situation, I'm looking for angle B. That's my question mark. I've got a side opposite. I don't have any other angles. That's a law of cosine situation. Okay, now this one is an interesting problem. I'm looking for y. which is a side opposite of an angle. Okay, I've got an angle and a side opposite. Now, we would look at this and say, well, do I have to use law of cosines? And the answer is no. This can be a law of sines situation. What we have to do here is we would just have to subtract these two from 180 to get our upper angle, and then we can use law of sines. Okay, now, last problem here, we're trying to find the measure of angle C. Trying to find the measure of angle C, side opposite. I don't have either of those. But now if I look at what I have B and side opposite. I have a side opposite of A. So what I can actually do is use law of sines to find A, and then once I have A, I can solve for C. Now, what we're going to do next is we're going to just run through a couple problems of each type as a way to review right triangle trig, law of sines, and law of cosines. So now, looking for this problem, what method would I use? Okay, hopefully you noticed the right angle from the start. So this would be a right triangle trig, and we're going to use either our sine. So we've got our so, ka, and toa. Okay, so based on our reference angle, we always want to think about where we're standing. We label our triangle. The hypotenuse never changes. X is the opposite. 30 is the adjacent. So now I've labeled this triangle based on the angle that we're working with. I have an opposite is what I'm trying to find. I'm given the adjacent, so I need the function that uses the opposite and adjacent values. So I've got the tangent of 38 equals opposite x over adjacent 30. Now remember, in this situation, put a denominator of 1 on your trig function, because then it allows you to cross multiply and solve. 1 times x is x, and then we have 30 times the tangent of 38. Okay, so we can finish this up. Tangent of 38 is 0.7813 times 30, and we get 23.4 for x. And our unit here is centimeters. Okay, now this next problem. We can see that it's not a right triangle situation. So what we're trying to do is we're trying to solve for y. So I have an angle and a side opposite. But if you notice, I don't have either of those angles. So this is not going to be a law of sines, because if I'm missing a side, I need two angles for law of sines. So this is going to be a law of cosines problem. And when you find your angle and side opposite, that is defining the value of C for you. It doesn't matter what the letters of the triangle are. We need those two pieces where the y is going to be by itself, and the 78 is what we're going to find the cosine of to tack on to the end of this equation. So now, finishing it out, 32 squared plus 42 squared minus 2 times 32 times 42. Okay, and then we have to go through and multiply out these values. Now, if you notice, everything is on one side. So I'm going to type this in my calculator in one string of values. 32 squared plus 42 squared minus 2 times 32 times 42 times the cosine of 78, and I close the parentheses, and I get an answer for y squared of 2,229.1 rounded to one decimal place. And then I have to square root both sides to get my answer of y equals 47.2 centimeters. And remember, in geometry, whenever you get an answer, look at your answer with respect to the shape and see if that answer makes sense. Okay, 47, a 78-degree angle is going to be one of the larger angles of the triangle. So there's a good bet that y is the largest side of the triangle, and that makes sense in this situation. Okay, our next example here. Okay, we're always looking for pairs, seeing what we have. Okay, we need an angle if there's a side opposite. I've got an angle and a side opposite. So I'm really close to law of sines here. I just need that upper angle. Okay, and you always want to look, can I find that upper angle? And in this case, I can. 180 minus 76 minus 24 equals 80. Okay, so now I have that missing value. And now, based on my angle, side, opposite, I see that I can set up a law of sines here. And then looking at the angles of the triangle, I know that W should be the largest side. So if I get an answer under 15, something's wrong. I have to go back and check my work. So we set up our law of sine. Sine of 80 over W equals sine of 76 over 15. Okay, and then it's just a cross multiply and solve situation. W times sine of 76 equals 15 times sine of 80, and then we divide both sides by the sine of 76. Okay, now you can turn these into 4 decimal place numbers if you want. Okay, your answer is always going to be most accurate if you use the sine functions as you're typing through your answer. So when I'm typing this in, 15 times the sine of 80, enter, and I get 14.77 divided by the sine of 76, and I get an answer of 15.2. Okay, notice it isn't much bigger than the 15, but if we look at how close the angles are together, we've got an 80 and a 76. Okay, we can definitely see that those angles are very close to each other, you know, so the side length should be very close to each other. Okay, now, last example for today. We saw this in one of our last lessons. How do we find the area of the triangle? Now, when we're finding area of triangles, what we need is we need an angle, and we need the length of the two sides that make up that angle. And in this case, we do. And then we can use our area formula, 1/2 A times B times sine of C. Okay, so we've got that opposite over hypotenuse situation. And what that does is that actually creates the height of this triangle if we're doing an opposite over hypotenuse situation. So in this situation, what we're actually doing, we're using 21 as the base. We're using the 72 and the 38.45 to create a height here of this triangle. So we plug in our pieces, 1/2 21 times 38.45, and then that is times the sine of C, which is 72 degrees. So we have 21 times 38.45 times sine of 72, and then I'm going to divide that by 2, and I get my area of 384.0. It's actually 383.97, so I'll just leave it there and we could round it how we needed, centimeters squared. Okay, so that concludes our lesson for today, where we're deciding between when we use right triangle trig, when we use law of sines, and when we use law of cosines. Thank you, and have a good day.